I want to talk to you guys about some properties of trapezoids today. So we're going to talk about them, not in too much detail, more to get you guys what you need, and then we will talk about, I might make a video tomorrow just explaining why some of this stuff works. So first of all, we have two different types of trapezoids. We have just regular plain old trapezoids, and more specifically, we have isosceles trapezoids, okay? So this is a trapezoid over here, okay? And this is an isosceles. Isosceles, I think I actually can spell that now. This is an isosceles trapezoid, okay? And we said that they both have in common is that they both have a parallel set of sides that we call the bases. Okay, so these are the bases. The only extra thing we said we knew about an isosceles trapezoid was that your legs were congruent. Okay, so if you remember from last time, the top and bottom are your bases, right? The parallel sides are your bases, and the other two sides are your legs. So the only thing we know extra about an isosceles trapezoid is that these two sides are also congruent. Okay, now a couple things we know. We know that they have to have 360 degrees altogether, right? We should know that already. The additional piece of information we know now that you're going to see today, and again, like I said, I'll make a second video kind of proving all this stuff tomorrow. I just want to get you guys up and rolling with this so you can do some of the work. The additional thing we know now is that we know angle A and angle D, in this case, have to equal 180 degrees, and angle B and angle C have to equal 180 degrees. So, in other words, if I take any pair, okay, from the same side, they will have to go ahead and be supplementary. So A and D are supplementary, B and C are supplementary. So with an isosceles trapezoid, because the legs are congruent, you also have your base angles being congruent. If you remember, that was true for isosceles triangles as well. And again, I said we'll go over why tomorrow, but for now, just take my word for it. All right? Well, if these things are true, then I know angle E plus angle H equals 180. But I also know that angle E plus angle G equals 180, right? Because if these two are the same, and I can add these together and make 180, then I can add these together to make 180, okay? So pretty much what you're allowed to do is you're allowed to mix and match any top angle with a bottom angle. So I could also say angle F plus angle H equals 180 degrees, okay? So again, just you can mix and match any top angle and bottom angle and have them equal to 180 degrees, okay? Now, I'm going to skip over to just isosceles trapezoids now because these things are only going to apply to them. And there's a couple more rules. Actually, no, I have one more thing that's going to apply to both. But for right now, let's just talk about this, okay? So if I have an isosceles trapezoid, one of the other things you need to know is that when you draw the diagonals, okay, and otherwise I connect corner to corner, your diagonals will be congruent. Now, again, like I said, we'll prove this tomorrow because if you can see, there's a bunch of triangles in here, and that will mean some triangle-proof stuff, but nothing too heavy. But what you need to know is that these are congruent. Okay, so if I had A, B, C, D, and this is for isosceles only, AC is congruent to BD. And if we want to, we can actually take this a step further. I'll label this middle point AE. I could actually say that AE and BE are congruent. I can also say that DE is congruent to EC. So you have all these things kind of being true, and that all hinges on the fact that these sides are congruent. Okay? And again, so I said we'll go over why tomorrow. I just kind of need you to know that. Okay? The last thing we need to know is probably the most complicated one, so we'll probably take the most time to talk about it. I'm going to draw an isosceles triangle, an isosceles trapezoid, but just this applies to both. So I'll go over it a little bit here, a little bit there, I suppose. Okay, and that is this. And let's label this as the trapezoid mid-segment theorem. Okay. So first of all, if you remember what a mid-segment is, a mid-segment is if I cut the two sides in half. If you remember, we had a triangle mid-segment theorem way back at the beginning of the year, and if we need to go over that again, we absolutely can. But essentially what it means is this, is that your mid-segment is going to be the midpoint of this. So it's going to cut these into equal parts. And I'm going to go ahead and specifically label this as being a different length because this applies to isosceles and non-isosceles. What you need to know is if I go A, B, C, D, and E, F, that if I add together A and B, A, B, and E, F, and I divide by 2. In other words, if I take the average of this top and this bottom, I will get the middle part. So I will say AB plus EF. Okay, and there's two ways to look at this. I can say this is divided by 2, right? Or I could say AB plus EF times 1/2, right? That's another option. But whether you do it or not, that's going to equal the length of CD. Okay. Again, a third way to look at it is if I add up the two of these, AB and EF, that's going to equal 2 of the middle one together, right? Again, it's the same thing here. I just multiplied by 2 on both sides, okay? So bare minimum, CD, the central one, is the average of the top one and the bottom one. And well, again, like I said, tomorrow we'll go over why that's true and how that relates to the triangle mid-segment theorem, okay? But again, what you need to know is that essentially the top one and the bottom one divided by 2 is going to equal the central one. So I want to go over a couple of those, and then you guys can go ahead and take it, okay? So I took these straight off IXL, so these are the types of questions they're going to ask you. So it says PS is the mid-segment of trapezoid QRTU, okay? Essentially, they want to know if PS is 25 and TU is 32. We'll do this one first. There was a different one I want to do first. Yes, I'm sorry. I want to do this one first, okay? QT is the mid-segment of trapezoid RSUV, okay? RS, okay, go ahead. Let's label this out. RS is going to be 35, and UV is going to be 51. How long is QT? Well, again, all I need to do is take the average of these two numbers, and that will give me QT. So what am I going to say? I will say RS plus UV over 2 is equal to QT. So let's fill in what we know. Right? So RS is 35. UV is 51. What is QT? I'm sorry, I should probably fill these as segments. Okay. Now 35 and 51 is going to be 86. Okay. And QT is going to be half of that. So 86 divided by 2 is going to be 43. So QT is going to equal 43. Good things to watch out for. Obviously, if it's in the middle, it has to be in the middle of these two numbers, right? Okay. Again, it's not half of the top. It's not. I'm sorry. It's not half of the longer. It's not double this. It is the average of the two of them. Okay. Why I wanted to come back to this one second was that it's set up a little bit differently. So I said PS is the mid-segment. PS is 25. QR is what we want to know, right? And what else did they give you? And TU is 32. Okay. Well, again, let's go with what we know. We know that QR plus TU over 2 is equal to PS. Okay, so let's fill in what we know. We know that PS is 25. Right? We know that QR is what we're trying to find. We know that TU is 32, and we're going to divide by 2. Now, before you go and start dividing by 2 over here, do yourself a favor. I'm going to multiply this side by 2, and I'm going to multiply this side by 2, right? So let's get rid of the fraction. We'll say QR plus 32 is equal to 50. Again, if you're more comfortable just setting it up like this, you can just set it up like this right from the get-go if you'd like. Okay. Again, now pretty straightforward. Let's subtract 32 from both sides. I'll find out that QR is equal to 18. Okay, again, does it make sense? Yes. Okay. 18 and 32 is 50. 50 divided by 2 is 25. All right. There are some more complicated ones that you guys are going to see in there. Again, I want you guys to get this started today. If you can't do all these today, that's fine. You're going to have 2 days to do the same assignment because I'm going to go over how and why all these things work tomorrow. So the UZ is negative 2p plus 19. VY is going to be p plus 8. And WX is going to be negative 9p plus 62. And they want you to solve for p. Okay, so let's go ahead and let's set it up. We know that it's going to be UZ plus WX over 2 is going to equal VY. Okay, so let's fill in what we know. UZ is going to be negative 2p plus 19. WX is negative 9p plus 62. Okay, so just substitution. Let's put those all over 2. And that's going to equal p plus. Okay, first thing we said before, let's multiply both sides by 2. Okay, let's multiply both sides by 2. Don't forget to distribute. So these are going to cancel. So what do you be left with? Negative 2p plus 19 plus negative 9p plus 62. Again, let's distribute 2p plus 16. Okay? All right, so now let's go ahead and simplify. Negative 2 and negative 9 is going to make negative 11. 19 plus 62 is going to be 81, I think. Yes. Okay, and that's going to equal 2p plus 16. Okay, let's go ahead and let's add 11p to both sides. Okay, so now we're just back to just regular old equation solving, right? From here, you know, you guys should probably been able to do this in about 7th grade. Okay, so we're just building up on those skills. What do we got? We have 81 is equal to 13p plus 16. Let's subtract 16 from both sides. 13p is equal to 65, which means that p is equal to 5. Okay, so p is equal to 5. Again, if you want to check that out, see if it works. So if p is equal to 5, that is your answer. But again, if you want to check it, negative 9 times 5 is 45. 45 minus 62 is going to be 17, I think. Is it 17? I believe. Okay. Plug in the top. So what do we got? We've got negative 10 plus oops. Yeah, let's plug it. Let's take our time. Negative 2 times 5 is going to be negative 10 plus 19. Never mind. Never mind. Negative 10 plus 19. What do you get? You're going to get 9. Here, 5 plus 8 is going to be 13. Okay. And negative 45. Negative 45. Negative 45 plus 62. Again, it's going to be 17. 9 and 17. 9 plus 17 divided by 2. Will give us the 13 that we were looking for. Okay. So again, if you want to plug the numbers back in and check them, please by all means do it. Again, let's go right through this. Just one more. This last one. Okay. All right. Again, here's same kind of question. QR. They gave you 4W minus 6. PS is going to be negative 4W plus 49, and TU is going to be 4W plus 8. So again, let's go ahead and let's say QR plus TU over 2 is equal to PS. Okay, so from what we know, QR is going to be 4W minus 6. TU is going to be 4W plus 8 all over 2. And that equals negative 4W plus 49. Now here, if you want to divide by 2, yes, since these are all even numbers, probably not the worst idea. I'm going to stick to multiplying by 2 on both sides. 4W minus 6 plus 4W plus 8 is equal to negative 8 plus 98. Okay. What do we got? Again, 4W and 4W is going to be 8W. Negative 6 and positive 8 is going to be 2. That's going to equal negative 8W plus 96. Let's add 98 rather. Let's add 8W to both sides. 16W plus 2 is equal to 98. Subtract 2. We'll find out that 16W is equal to 96. Sorry, hold on. Phone's ringing. Sorry about that. And last step here, of course, we're going to divide by 16. We'll find out that W is equal to 6. Okay. And again, if you want to plug that back in and check it, it's right. Okay. So again, like I said, that should give you enough to start. I'll make you guys another video tomorrow explaining why some of the stuff works. But take it easy. I'll let you guys know.